Okay, so hopefully you got to this part where I found some of the values, not as many of the values when we did the sine function, but a few key values. And if we graph these, we can see that the trend of the graph is very similar to the trend of the sine graph. So if I plot these points that I have, again, I'm going to go from 1 to 0 back to -1. So when you're graphing your y-axis, okay, a sine function and a cosine function, the maximum value is going to be 1, the minimum is -1. So that's how you know where to graph these points. Then I just have to graph the points in between. And so I graph the ones I had. And then I'm just going to kind of extrapolate by looking at the graph of the sine function. In other words, the cosine function goes like that. And knowing it goes down, I know it's going to come back up. Now I'm kind of careful. And so basically my target points, I make sure I always graph the pi point, the pi over 2, because that's 1, and that's 0, and that's 1. And I know it's going to have this kind of curvy slope down into the valley, curvy slope back up to the top. Okay, so the cosine function, if you look at your sine function, it's very similar. See, that looks too much like a V. It should not be a straight line going from here to here. It should be going up a hill, and then the hill flattens out. Okay, so it's not straight between the two. It's got to be a nice curvy slope. You're going to get really good at these after doing lots and lots of them. All right, so that is your cosine function. I could continue it backwards and forwards because it's a periodic function. It's going to repeat. So whatever you just did is going to do it again and again and again. Okay. So sine and cosine are considered periodic functions. The graph repeats the same values again and again. Now, we talked about this before with a periodic function. The distance along the x-axis these graphs take to complete a full cycle is called the period. Okay? What do you think the period for a sine function is? 2 pi. And what about a cosine function?
2 pi.
2 pi, also 2 pi. So both will repeat after 2 pi. So wherever you start, if you look 2 pi later, you're going to get the same exact value. It repeats. It's cyclical, again and again. Okay? Now, the tangent function. This is a weird one. Okay, this is going to look totally different. It is also a periodic function. Has a different graph. Because the tangent ratio is the ratio of the opposite leg to the adjacent, it's not limited to -1 and 1. In fact, it can go up to infinity and to minus infinity. Right? So we'll see what the graph looks like in a second. But you know how there are undefined values because you can't divide by 0, right? So wherever the cosine of theta becomes 0, it's undefined. Can't have a 0 denominator. Since we have sine theta over cosine theta, that's the definition of tangent. Wherever cosine theta goes to 0, you're going to get undefined, or an asymptote, which we've seen before. So let's take a look at the graph. Those happen, by the way, those asymptotes are going to happen at pi over 2 and 3 pi over 2. Now think about that, right? Here's your unit circle. Cosine is the x value, right? Cosine is 0 at minus pi over 2, or in this case 3 pi over 2, right? Down here, cosine is 0, and cosine is 0 up here. So those are the two places, those angles are the two places on your unit circle where you're going to get undefined values. All right, so when I want to graph a tangent function, and for your assignment tonight, you're going to be graphing it from scratch. And there's all the values. They're all laid out there for you. Okay, so you're going to go ahead and graph this. What you do is you figure out where the asymptotes are. Okay, so you always plot the asymptotes first. Where did we just say they are? Where do we say the asymptotes are? Pi over 2 and 3 pi over 2. So I'm going to make a little dotted line at pi over 2. I'm going to make another one at 3 pi over 2. A vertical line. Okay, vertical dotted line. So there they are. Okay, these are my undefined values. Let's pause. These are my undefined values. Here's an asymptote right here. Here's an asymptote right here. Now I'm just going to work through each of these data points again. Now tan theta is a little more tedious because you have to figure out the sine and divide by the cosine. Or you could use radians in your calculator, right? You could say, get it in radian mode, and say the tangent of pi over 6. Okay, and you can just plug in the decimal value. That's fine. You guys have done this enough times with that big old table. Remember that big old table? You could just look at that to get those values too if you want. All the values for tan of all the different angles. But that's what you're trying to figure out, is what is the value of the tangent for each of these different angles. Once you figure them out and plot them, you're going to get a graph that looks like this.
What?
I just grabbed this data. It's going to give you this graph right here. Now, what's interesting about that is it goes negative. Don't just copy this down, Will. I know you're trying to keep it. Yeah, I don't want you to copy these down right. Just pay attention to this. Pay attention to what's going on with the graph. Okay, so here you have undefined. It goes from negative infinity, and it works its way up. You got a data point here, data point here, data point here. This is the key data point. Right in between the asymptotes, there is a 0. Okay, that's where it crosses the axis. Why? Because the sine of theta is 0 here. Okay, at pi, 180 degrees, right? 180 degrees. Here's my unit circle. Right down here, at 180 degrees, sine, the y value, is 0. So at pi, you get a 0 of your tangent function. And then it climbs back up until it reaches infinity. In a tangent function, just like a sine and cosine, all you have to do is graph one period. Once you graph one period, then you just draw the other asymptotes. They're going to be every pi. From here to here is going to be pi. So minus pi over 2, this is minus pi. I'm sorry, pi over 2 from here to here, pi over 2 from here to here, pi over 2 from here to here, etc. So from here to here is the distance of pi. So once you get one graph, you just do all the other asymptotes and you space them out evenly, and then you just repeat. And you just recognize the periodic nature. So graph it once, and then repeat the function several times, etc. Okay, so what is the period of a tan function? Well, what was the sine and the cosine? What was it again? What was the period for a sine function? 2 pi. Every 2 pi it repeats. Tangent function is different. Every 1 pi it repeats. Okay? And that's it. That's the end of the discussion. So you're going to go ahead and graph by hand, sine, cosine, tangent. That's your homework tonight. That's your homework this weekend. And then you're done.